My name is Nicolas Roard. This is John Hoford, and I'm the tech lead on Android Studio for the design tools and ConstraintLayout. And John?
I work on ConstraintLayout and on the GUI builder.
So we're going to talk about ConstraintLayout, and just a little bit of background why we created ConstraintLayout. Well, the original idea was we wanted to have something, a new layout manager that would support like flat layout, and also maybe a layout manager that would be more expressive for creating UIs. And finally, we wanted something that was built from the ground up to be well supported into the visual editor of Android Studio. So just to give a quick example of what we mean by flat layout. So if you have something like that, that's a reasonably complex-ish screen. Typically, you'd build something maybe with, you start with vertical linear layout, and maybe there is a relative layout so that the star image is correctly positioned. Another linear layout, because why not? The text view, couple of horizontal linear layouts to get your rows. Some text view to all the comments. Finally, a row for the buttons. And not saying that we couldn't do better, but that's I think a pretty common UI. The problem with that is that, well, you got even with something like that, you have a hierarchy that's a bit deep, and one issue is performance. The deeper the hierarchy, the more problematic performance can become. The other issue is that you are very locked into that design. If you really want to change things, well, you kind of have to redo everything. But if, for example, this particular text view needs to be recalculated, like its size needs to be, like you change the text, for instance, and the size of the text view needs to be calculated again, that will actually impact all those containers. So it can very quickly be relatively expensive. And if you are just doing a screen, that may not be such a big deal. If you are doing something like list view or recycle view and stuff like that, where you constantly recalculate stuff, that could lead to bad performances. So with ConstraintLayout, the idea is, well, we don't do any of that. All of your views are just that, views, and they're just laid flat into the layout. And instead, what we have is we have a system pretty flexible to specify how those views are positioned relative to other views or the parent.
So the best way to use ConstraintLayout is in Android Studio. And just to kind of give you an idea, the tool is designed to work really well with the graphical user interface. So here you see it making some constraints. On the left is a tool palette. On the bottom left is a list of all the components. On the right is an inspector, which will show you the state of all of the pieces.
And that one that you're just seeing right now, that looks like a blueprint. It is a blueprint. So if I go back on that screen, it's the blueprint. You can think about it as a way of, it's like an X-ray on your layout. It shows you all the connections, all the constraints that are applied to the element of the layout. But you would notice that it's actually showing you just the bounds and what's actually there. So the difference with the design view that shows you how it looks like on the device is that it's kind of a separate, different type of information. So sometimes you really want to see how it looks. Some other times you're more concerned about the rules, the constraint that you set. And sometimes you want both, right? So in Android Studio, you can actually have both side by side, or you pick one. That's really easy. So, we just show you briefly in Studio how it works, but fundamentally, the general concept is that you got those circles there on the frame of the buttons. Those are called anchors, and you can connect those anchors together. Once connected, they basically maintain a relation, a constraint, and you can associate a margin. So that's the simplest way to think about ConstraintLayout is that you position an element relative to another one. In many ways, it's close to a relative layout, but it actually goes much further than that, as we'll see. So the other important things to think about when you work with ConstraintLayout is that every widget needs to be defined, its position needs to be defined basically on the two axes, horizontal and vertical. So you need at least 2 constraints per widget. So if you don't have constraint, that's no good, right? So keep that in mind, if you need at least 2 constraints. The thing though is that while you are editing, while you're in Studio and you're just playing with your UI, if you don't have constraint, that's not a big deal. We'll just let you move the widget wherever you want. So that's kind of the idea. We'll keep it flexible while you edit it. But do remember that if you don't have those constraints set, when you push it to your device, your screen may not look the same because everything will resolve to 0, 0. So beyond that, that's really the gist of it. And the library itself, it's a small unbundled library. So it's 130 kilobytes at the moment. It's not really going to be a problem for your APK, I hope. The fact that it's an unbundled library is actually very, very interesting for us, but I think for developers as well. It's good for us because we can push new version anytime, and we definitely did that. But it's good for developers because it's not like we can push a new version and suddenly it breaks your application, right? So no, you are in charge, you take the library, you decide to take the latest version or not, it's up to you. It's built upon a very flexible foundation. So we have this very generic linear equation solver. So all those constraints are in fact expressed in terms of mathematical equations. We thought that maybe letting you write your layout using math may not have been the most user-friendly experience. So on top of that, we built this constraint system that's a lot simpler. And at the same time, we try to keep it very flexible. One big thing that we did since we announced it at I/O last year is this mechanism of doing direct resolution. So whenever we can, we try to take the constraint system and directly solve it without even going through the linear solver. So that's kind of like getting the best of both worlds. We do get the expressivity and the power of having a full-blown linear system solver. But on the other hand, whenever we can, and it's easy enough for us to solve directly, we do. So we get a lot of speed out of that. And as I said, we try to build it with the UI builder in mind. And the other part that we have, that's not really in the library, but that's we think about it as part of the same system, is an inference engine that runs into Studio that basically create the constraints for you. All right, so right now we are at version 1.0.2. We've been doing 16 updates since last May. So we've been keeping a pretty good pace, trying to be pretty reactive about user feedback as well. It's a lot faster than what we showed at I/O last year. Hopefully it's less buggy. We have a ton more features, better support in Studio. If all you tried was the version of Studio that was released at I/O, since then we released the 2.2 final and we released the 2.3. You really should take a look at 2.3. It's much better, particularly for the layout editor. It's also became the default layout in Android Studio. So if you create a new screen in Studio, by default, you'd use ConstraintLayout because we thought that was actually the best, the more flexible solution if you just wanted to throw out the screen. That doesn't mean you can't use the other one. Obviously, we still work with them. And there is some good use cases for those as well, but that's where we are right now. Okay, let me quickly cover the possible constraints that we support, the way you can express the different positions. So you can think about it as the grammar of the system, right? It's like, you got all those new concepts and how can you create a UI from it? So you got the relative positioning. As I said, very similar to what relative layout was doing. And in terms of the XML, it's pretty similar actually. It looks a bit scary like that, just seen on the one slide. But in fact, the only thing that you really should care about are those 4 lines at the end describing the 2 constraints that are here on the left, one for the top, one for the left, and the associated margin. And the only thing you need otherwise is an ID for the target. Obviously, you need to be able to reference it. And in fact, if you look at the diagram, something to keep in mind is that all those lines, they actually mean something. And in fact, you could think that 1 line is equal to 1 constraint, or 1 line on screen is equal to 1 line in the XML. So we do more so than just left, top, right, bottom, or start and end. We also support text baseline, so you can just position, using the text baseline, which can be pretty handy. We have this concept of bias as well. So if you have like a button like that, and you have it connected on two different constraints, like two different anchor points on either side, by default we'll center it, but we can actually specify a bias, so you can make it more or less off-center, and we can think about it as a percentage-based positioning. And those two anchors that you connect to, they don't have to be just a parent, they can be anything, any other widget. We also have a quite extensive system for specifying the dimension of a given widget. So we have the usual, the wrap content or the fixed size, and I'm hoping that everyone knows, but wrap content basically asks a widget, what's your size? Give me your size. But we introduced something called match constraint, which actually in the XML is just shown as 0dp. It's very similar to what linear layout does for those who are used to that. And match constraint goes a little further. But basically, if you want to see a visual representation of it, it's like wrap, well, you got the size of the widget as much as the widget wants. Match is going to be expanding, spreading the size, the dimension of the widget as much as possible to match those constraints. And I didn't show it here, but if you define margins, the margins are going to be subtracted to that space, or some random fixed size. So match constraint can actually do a lot more. One thing is that the default behavior is spread, which is what I just showed, but you can also make it wrap. And what that does is that the widget will act like if it's set to wrap content, but if it goes beyond, if the wrap content size of that widget goes beyond the constraint set, then they will be limited by those constraints. So that's kind of a pretty interesting feature. We can also specify a ratio, which is defining one of the dimension, like width or height, using the other one. If you're using the widget in a chain, and I'm going to define chain a bit later, you can specify a weight as well, which is very similar to what linear layout does. And you can also specify min and max if you're using match constraint, right? On Android, you can specify min and max on some widgets. Some widget knows what to do with a min and max. But here, any widget would work as long as you specify match constraint. We also, and that's an example of max, for instance, right? So the widget is set as match constraint in width, connected to a guideline. But if I expand that, it will go up to a certain amount. There's an example of aspect ratio, and you can set it in the editor. And you can see it like going from 16 by 9 to 3.2 or 1.1. And one aspect of constraint layout that I particularly like is the way we handle GON. So on Android, you can specify the way a view is going to be shown or not. Like it can be either visible, invisible, meaning that it participates into the layout, but it's simply not rendered, not drawn, or GON. And if you used relative layout in the past, well, the way it handles GON behavior is not always particularly great. But in constraint layout, it's very well specified. So if a widget is marked as GON, it simply reduces to 0, 0, and the margin is 0 as well. So in cases like that, that works really well. But if you're changing the GON state on the first widget, you see that may not be what you wanted here. And it completely makes sense, right? Everything goes to 0, so we got all those things going back to the origin. But what you can define is an alternate value for those margin if you're connected to a widget that is GON. So then you can specify, well, when it's GON, I'm actually going to use like a 32 dips top margin for the button, and so everything goes at the right place. And I briefly showed margin earlier, but guideline, sorry. But guideline is basically a way to help you set up a UI. So think about it more like as a helper object rather than a graphical component that you will have in your screen. And if you've been working with designers before, so sometimes they call them keyline, red lines, guidelines. Basically, those are the vertical or horizontal line. And you can position them either relative to one side or the other, or as percentage. And finally, chains. So chains are defined in a very simple way. It's simply if you have at least two widgets that are connected with a bidirectional connection. So A is connected to B and B is connected to A. If you have that, that forms a chain. And when we have a chain, we handle those widgets that are part of the chain in a little bit differently. So we consider them as a group, in a sense. So you can think about chain as a way to define a group without having to create a nested hierarchy. Another important point is that chains can work in a single dimension. So you can define a chain, let's say, in the horizontal axis, but in the vertical axis do something completely different. So that's quite different than, let's say, linear layout, because linear layout will define the position of the widget on both axes. And we have various styles of chain that you can easily specify. Some very similar to linear layout, others a little bit different, but you have quite a lot of expressivity. And to create a chain in Android Studio is pretty easy. You just select those widgets, click on center, and the way center works will create those bidirectional connections, therefore creating the chain. And once the chain is created, you can easily toggle the different style. Let's talk about tools.
Okay. So inside of Android Studio, we try to put a rich set of tools for you to use these constraint layouts. We have a lot of them are like the regular things you'd think of in any drawing program or PowerPoint or something like that. Align left, align right, that sort of thing. And some of them are a little bit unique. One of the things the ones that you see with blue lines on them, for example, the one that just did the constraints, they actually can create actual constraints for you. So if you say align left, it'll create a bunch of constraints that effectively align the collection of things you've selected to left. If you don't want them to actually create constraints, but you're just practicing the layout of everything, you can press Control while you issue the operation, and it'll align them left like you did in PowerPoint, right? It'll just push them to the location you want them to be in. And you can see you can create vertical guidelines, etc. A lot of them are also available on right shift or right click. So here's a little example where you see how you would create you aligned a bunch of them and made a chain, and now I'm going to align left a bunch of them, then make a few manual connections to finish it all off. Now, one of the nice things that we did for constraint layout is that if you just manually positioned everything very accurately, this button, the two stars, and apologize for the icon, I didn't do the icon. The two stars will actually try to infer what constraints to place. So it'll automatically create the collection of constraints for you. And in this particular case, you see it did a pretty good job. It has a few kind of rules that you kind of have to expect. One is that it's not going to try and move widgets. It doesn't beautify the image. It doesn't position things where it should be. You have to position it where it should be. It will then use those and try not to move them. The other thing is if you make existing constraints, it'll honor those and then add whatever's missing. So a common use case is before you finish, just hit this button, and any constraints you missed, it'll figure out and put it in for you. So it's like a quick shortcut. A lot of people use it as a way to finish their layout. Some other people lay out one by one, hitting infer as they go to try and have it add constraints incrementally, and that will work as well.
All right.
So,
yeah, actually, that's studio, right?
Yeah. So So one of the other things that we added to is something we call a constraint set, and a big use case is animation, and we'll see a few examples of it later. One of the things you can do with a constraint set is have a layout and get the actual constraints from that layout separate from the layout. And then you can apply it onto the layout that's there. So you can switch between two constraint sets. Sorry about that. And I'll just power it off. So the example here, I create two layouts. One of them is it has a small image, and the other one has a bigger image. And then I'm switching the constraint set. Turn that off for me. I'm switching the constraint set. So here you see I've created two constraint sets, and I'm cloning a layout. Another way, I'm cloning another layout, and then I can use those to apply the constraint sets to an existing layout that's on the screen. The big advantage too is that you don't actually recreate all of the views. It's actually just positioning views at this point. The other thing is we can use some really wonderful APIs. Chet wrote along transition manager, begin delayed transition. And so that when you apply the constraint set, it will actually animate from one to the other. And in fact, the transition manager is very, very powerful tool for when you want to make animations. And you'll see more examples of that as we go along. Another example of it I'm showing here is where all I'm doing for each view is setting its height as I move along. And since they're in a constraint set, they all have to, they all react to that constraint. And because I'm using the transition manager, it's animating them gracefully. So you can create lots of surprisingly easy, quick, subtle animations with things like that. And so essentially all I'm doing is wherever my finger is, I set the minimum height to 400 and the rest of them get set to 0. Okay,
so let's just cover a few examples of how you can actually use constraint layout. So you have all encounter this type of example, this type of problems. You want to have a simple row, and an image on the left, some text here and there, maybe some image on the right. And there is a couple of subtlety here. But basically, the way you would do it with constraint layout is relatively straightforward. You have the image that's connected on the left. You have the image on the right that's connected on both top and bottom and the right. Same for the image on the left. And the text are just simply relative to that image. One thing that's actually interesting is that the image on the left is the one driving the wrap content of that row, meaning that the size of the row is completely dependent on the size of that image. But what's cool is that the size of that image is actually set via a ratio. So as long as you set the ratio of the image right, it will basically derive the entire the rest of the dimension of the row. And while we are talking about row, and it's something we want to get better in Android Studio, but you have actually quite a few things that you can do with Studio to more easily display stuff like that. So we have this concept of the tools attribute that in essence allows you to override any attributes of the XML object and to replace them with a value that you would use only during the design times, only in the editor, right? And that's quite useful if you have, for example, a layout that, in fact, in your application is going to be fully filled programmatically. Well, how do you deal with it in the layout editor, right? Well, if you use those tools attributes, you could just put some random attribute and you will have a look and you can see what it looks like. So the list is on that URL on the bottom. But the one I'm using here is interesting. That's just a recycle view. And you can just do tools list item, passing the layout, and you can see what it looks like. So here, that's just a recycle view, but that would work as well if the layout was a bit more complex than a recycle view, than just a recycle view. And you can see it like in Android Studio. And you see like on Studio, you got on the inspector, you see this list item with a little, tool icon. So that's what it means. All right. So another example. If you see a screen like that, you say, well, you definitely can do that with linear layout, right? Maybe you put one space object above, one space object below, make them, weights, and that will center your thing. Problem comes when the layout may be, and this is how you would do it in ConstraintLayout. Basically, this basically put those widgets, create a chain, make it a packed chain, so it will be all centered, and that's it. But the problem with that is, if you use something like linear layout to do this layout, if the height of the layout goes, is not enough to contain those buttons, what do you do? Well, with constraint layouts, because you defined it with the constraint on the image, with the match constraint, the image can simply be set to be wrap content by default, meaning that it won't expand more than that, but will reduce in size if it needs to be squished a little more. And that's what I just explained.
So here we just wanted to start to give you some more sophisticated, more complicated examples to try and give you a sense of how you'd build about certain things. This is a regular dialogue. You'd see something like this, fairly common. And you can see we want to constrain things to the left. We want to put a couple of guidelines at 33 and 60%, put the image in between them, but set the aspect ratio so that it will always be a square. Again, centering and setting up our margins, usually where UX would have said. Now, one of the nice things you can do is when you build something like that, you could then build a landscape version of it, so you'd see the layout's a little different. There's only one guideline, etc. And in fact, you can use the constraint set to switch between them during rotation. So you can turn off the automatic handling of rotation, and it would naturally just handle this switching by using constraint set to set whichever one is the right layout for landscape or portrait. So the next, we wanted to show sort of a little bit more advanced use of animation. And in this particular case, you'll see there are quite a few interesting things going on. You see the shadows are raising and lowering as it goes. The image is getting bigger. A panel is opening up and some stuff is fading in. Now, one of the nice things about the way we did this and the way you can do this is you simply build two different layouts. This is the layout. One layout's on the left and one layout's to the right. You just you set all the properties like the elevation and things like that for the one that has the raised shadows. And as long as they're the same, you can actually then just say, use this transition set effect to animate between the two of them. But now you can actually take it and do some new things. So just recently, someone in Chet's team, Doris, produced physics-based animation, and we incorporated this. So we made a custom transition set that incorporated the physics animation into it. And it's the same effect, but with some extras. And you don't have to be as boring as the more traditional. You can come up with almost anything you want with this approach.
Yeah, and I think that's an interesting direction we can go with constraint layout, where you can use the layout more as kind of keyframes in your animations or different states, but you can still leverage the entire stack of the framework to really do awesome effects like that, and you have Transition Manager that in most cases is going to do a great job at doing everything automatically for you, but you can customize it pretty easily. So if you don't know this API, well, we have an expert in the room. that you may want to ask later. But there's a bunch of doc online, and I would encourage you to look at it. So what's next for Constraint Layout? Well, in general, we want to refine the Android Studio visual editor. As I said, the editor, it's not just about Constraint Layout. We support all the other existing view group, and we are working on that, as we talk, basically. But for Constraint Layout itself, we want to introduce this idea of having virtual containers. So we think that having this flat hierarchy is really useful, and particularly, you can think about it as decoupling completely the way the layout is made and the actual views that you have on screen. And I think, like, with animation, you can see how this idea can really show a lot of promises. So virtual containers, the idea would be that you would have containers that would help you, because sometimes if you set up a layout, if all you do is set the constraint one by one, that it can be a bit boring, and having a helper object that sets those connections for you can be really useful. So that's something we're working on. We also have some ideas about extra helpers object that would make your life easier as well. So the idea of helpers object is basically those objects that are mostly present for you to set up the layout, and that's more their role rather than the final thing. And finally, we have quite a few ideas as well to really bring animation to more staff, be more interesting. And that's the end of the talk. You can find more information online. If you encounter some bugs either in the layout editor on Android Studio or in Constraint Layout, please do file bugs. We do look at them carefully, and it's easy to contact us either on Twitter or.
Yeah, we're both very active on Twitter, so anybody has a problem, questions, we'll respond on Twitter. Okay.
Any questions?
No. Cool.
Yes?
So what happens is we actually sort of scrape the constraint set, the constraint layout information from one of them. So one of them is never inflated. It's just read, essentially. It's going through the inflator, but the information is just read off of it, so that we now know what are all the constraints to be applied. And there's only one set of views. One of them is used to load the views up on the screen, and then we just swap in the new constraint set and swap out the old one.
What's important to realize is that means that you completely control when you want to incur the cost of doing the inflation. So you can do whatever you want, and then once you have a constraint set being initialized, you can just set it on a constraint layout.
One of the things that's kind of attractive about doing it that way too is that when you're actually designing something like this, you actually are in the GUI builder, you arrange everything, you're in another GUI builder for the next frame. It's actually the next keyframe. And you're laying that one out and adjusting that one, and you can have 10 of them if you want. And they're all just graphically, so someone says, oh, I need this to be adjusted to the left. You just go in graphically and adjust it. And then you get the animation that will switch you between the two of them. And then you can layer more on that, as we saw in those pictures.
Yeah.
So you guys mentioned a long time ago about the desire to flatten constraint layouts that are nested. Is that part of the virtual container effort? Is that
It's a good question. It might be. So the idea is that if we have a constraint layout being a child of another constraint layout, there might be things that we could do to take advantage of that and basically be a bit more efficient. The original idea that we had for the virtual view group was to do something along those lines, but I think we found a better approach. we probably would still be able to do some optimization there.
Yeah, so if we do that, we'd have to have a key that says flatten this, and you would then, because that view that was the constraint layout within the constraint layout would no longer really exist, you couldn't like set the background on it, or, you know, there'd be a lot of limitations as to what you could do with a flattened constraint set. And so we still have to work out a lot of the details of how you would, what the API would look like, and what should we let the people like know about what they can and cannot do. We don't want an API that, oh, everything seems broken because I flattened it.
To that point, you know, the background example is interesting, because another example would be like if you have a chain and you want a background behind that, where you currently have to do like just an empty view or whatever to set that background.
Mm-hmm.
You could almost do, and you wouldn't want to do it automatically, but you have plans to support just like maybe a drawable.
Yeah.
Yeah, it's something we've
Yeah.
been talking about for a few months.
Yeah.
We haven't had, we didn't get around to implement it, but yeah, that's one of the ideas that's floating around.
Yeah. Essentially embedding a collection of drawables into the constraint layout directly with their own constraints, so that we can have them as floating underneath objects and things like that. Because a lot of people do it for, you know, they'll create a view to put a blue rectangle underneath something.
Or you want like a shadow of some kind.
Yeah. So we're looking into it. There are some implications, and you know, we're talking with framework and how would we make sure it doesn't break anybody. So, okay. Cool.
Okay.
Okay.
Well, thank you.
Thanks.